but I'll have a blue, 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 blue Christmas. Oh, hey, I didn't hear y'all come in. How y'all doing today? That's right, it's getting close to Christmas time, but well, I'm gonna start a little thing. I'm gonna call it Arc Start. So we're gonna get started learning some things about welding and stuff, and maybe that will help somebody along the way. I've been welding a good many years. I started trying to learn when I was 10 years old. I'm 67 now, and I'm still trying to learn. I don't know everything. I hadn't welded on a lot of this exotic stuff, and but there's a lot of things I've learned throughout the years and stuff. At one point, I was a quality assurance engineer for a major boiler manufacturer here in the United States, and welded there for several years. So the knowledge and the background that I have come from that through people that had been doing it for a long time. The techniques and the processes were proven after years of success in the field, and it worked out pretty good. So that's where I get a lot of my background. I know everybody's got a different way they do it and all of that, but we're gonna try to keep it just as simple as we can, because even though welding is a hard art to master, after you get it mastered, you think, well, that wasn't that bad. But anyway, that's what we're gonna get started on. Let's see how it comes out. Okay, let's take a 70-18. We're gonna start at the basics. A lot of you already know this, you've seen it or whatever. But the 70, that tells you the tensile strength of it. If you take this material right here and you take a 1-inch square bar of it and you put it in a tensile tester which pulls it apart, that thing should break at no less than 70 PSI, or 70,000 PSI, rather. Position, the next one is your position. 1 is all positions. 2 is flat only. Don't reckon I've seen anything other than that, but like a 70-24. That's pretty much for flat and all. Now, somebody say, I can weld up here with it. Well, okay, well, bless your heart. But the rod's made to run flat. And 8 would be the coating type on that rod, what it was, specifically designed to do. A 70-18 is a low hydrogen rod, which means that you need to keep them dry. I do have a rod oven here, but most of them I'm gonna use, we're just gonna pick them up. I got a can already open, and I'm gonna do that because y'all ain't got no rod heater neither, mostly. So you're gonna be doing the same thing. So I wanna try to mimic what y'all gonna be doing while you're welding. But the thing about a low hydrogen is, what is water made out of? Hydrogen and oxygen. What happens is when you get moisture in it and you weld it, that moisture the hydrogen will get trapped in there. It'll get trapped in that weld, and it looks like a little teardrop when you magnify it. At the point of that teardrop, that thing produces what they call a stress riser, and it can cause a crack to start there. That hydrogen bubble in that weld is gonna look, like I said, like a teardrop. That point right there is where the crack can start from or propagate from. Just like an undercut. An undercut, it's probably gonna start an argument with some people, but at the place I worked at, and they did a lot of research on this because boilers are constantly heating and cooling and moving and all of that, so they're constantly worried about crack starting. Well, if you got an undercut, if this right here is 3 times deeper than that is 1 time wide, that constitutes a stress riser, and that can cause that to crack because of the stuff moving and everything, and it'll come down to that point. It's got nowhere to go. If it's got something smoother than that, let's say like that, they can kind of go through it. But anyway, that's what they constitute a stress riser as of that. Same thing with an undercut. Well, I guess I done started it. We might as well keep on talking about an undercut right quick. I don't really have no plans on this. I'm just kind of talking off the top of my head. An undercut is caused by lack of feel. You're running too fast, you're running too hot. You might be running too hot, but if you slow down, you're gonna fill up that undercut. Unless we ain't getting into that. I ain't finna start that. We'll do that later as we progress on, because there's 100 different situations you can go through and find you some undercut, produce undercut, keep from undercutting. But anyway, an undercut, that's what it is. 3-to-1 makes a stress riser. Most of the time, your material, if you look at your a set of material data sheets, you'll get something, and Lord, this is coming back from years ago now. Material comes in, when you order material, let's say it's a 220 wall. If you take a UT gauge and check that son of a gun, it is just about gonna be 242. They give 10% on there because they want them, because that is a min wall specification. They don't want it any smaller than that, so they usually give you a little bit. A lot of people will tell you, well, at that place I worked at anyway, you're allowed 10% undercut. Why? Because that gets you right back down to there. 10%, but it still had to be less than 3-to-1 right there to make sure that you didn't have anything that's gonna be detrimental to that tube, cause it to start cracking. So the undercut to be detrimental to the part has either got to violate the minimum wall or constitute a stress riser. Other than that, that's just the inspector's call right there. A lot of them will say, well, I don't want you ringing the weld. You can't ring a weld. Well, they saying that because that's what somebody told them, and they can't prove why they do or why they don't. And it may be something in the books now. Don't get me wrong. Somebody can write that down there. I'm not fixing to go through digging the code to see. I know used to it never said anything about ringing the weld. If I rung that weld and I didn't violate the minimum wall and I didn't have a stress riser in it, it was perfectly fine with it because it didn't affect the fit, form, or the function. I just stepped on some toes, I know, but you can't prove it the other way. If you can, write her down there. We'll look at her and see. But now there at the same time, don't run getting in an argument with an inspector, because even if you think you win, you hadn't. Because you make that inspector mad, he gonna make it hard on you. Because you find out after a little while arguing with an inspector like wrestling with a pig in the mud. A little while later, you finally realize pig enjoying that. So a lot of the things that I'll show you is how to weld without undercut. Try to keep out all your cold laps, your cold starts. You don't ever want either one of those. Those are not good on a weld. Just so happened one time I tested so many times there at one time in the same place. I had to test. We turned around and got laid off. I was off for a little while. I had to come back test again. They lost those procedures. We had our qualification papers. We had to test again. And then I had to go back and do another test for a different qualification. So I spent a little time in the test lab there at one time. One of our tests was a heavy wall pipe in 6G. You took a coupon off from 10, 2, 4, and 8 o'clock on that. The 8 o'clock position I stopped and started in every time because I wanted to check to see if my tie ends was just as good as the rest of it. That piece tested and it passed, no flaws in it. So I want to show you how and why I do what I do, how I weld to make that happen so your tie ends will be solid and cleaner and won't be all knotted up and stuff. So that'll be a few more of the things that we go through on as we're going through this, but I don't want to try to overload you with a lot of information. Like I said, I want to keep everything pretty simple, and the techniques and stuff I'll show you is pretty simple to me, but there again, I've been doing it for a long time. I want you, when you get started welding, get you some scrap piece of plate. I want you to just sit there and just layer over it, layer over it. People say, well, that's boring. Well, it is, but there's a lot of time just sit there and spent. Folks say, well, how you start that 7018 off so easy? Started it off a whole bunch. Kind of like when I was bass fishing. Old boy told me, he said, you know, you keep throwing in that brush, you go to get it hung up, you can get it out of there. I said, have you noticed how many times I've been in that brush today? Had a lot of practice getting that bait back out of there. So anyway, it's the same thing. You got to practice and practice and practice on it. So that's going to be some of the things, and I'm going to give you a few things to work on, to practice on, to kind of help you get started. But there ain't nothing going to replace time under the hood. You're not going to sit there today and say, well, I believe I'm going to be a welder, and you sit out there and you practice for a week, and then you come out here and just all of a sudden you're going to haul off and go to pass and test and stuff. Ain't going to happen. You may, but I'm going to say most likely you're not. The vast majority won't. There might be one or two of you that can, but I seriously doubt that. But anyway, that's what we're going to do. I hope this series will help somebody, and you get something out of it. Hey, I'm open to any suggestions. I'm not a teacher. You know, that's not my do. I weld. I've had people tell me, well, you need to do something with your videoing and all. You need to do a better job of videoing. I'm not a videographer. I'm a welder and machinist. That's what I do. So some of it may be blurry. I'm still working. I got a fella gonna help me try to get to where we can see the weld a little better. When I do it, it's either too dark or too bright. So I want you to be able to see my puddle and what I'm doing with it. So it'll kind of help you out some on that. But anyway, well, we're going to move along. We're going to see what we're going to get into on the next section. All right, if you notice that rod right there, you see that bevel on it? That bevel was put on there by the manufacturer, so it would expose the rod, the electrode in the middle of it, so you can start it easier. Keep that in your mind now, because it's going to be a test on that. Okay, that's what I say. Now, this bevel, all welding rods has got this. And the purpose of that is so when it'll get right down there to the edge of the electrode in the middle, and you can start it easier. That's why when you got a rod you done already welded with, you got to pick on it to get that started, you get that knocked off of there. I want everybody to, when you light it off, as you light it off and you come back to it. Reason being, what that does, that gives that time to burn that from there down to here, and all that'll just kind of be on there. When you start welding over it, you'll burn that out so you don't have porosity. If you're welding boiler tubes, that's pretty important, because they're going to x-ray a lot of them, or all of them in a critical area on, let's say, a recovery boiler or something that uses black liquor to fire it with, because you get what they call a smelt water reaction if it blows out, and it'll blow the boiler up. I mean, it'll blow up. A lot of people say, well, I got hot start on mine, and that helps. If you're running a heavy weld, it's not quite as critical. But like I said, if you're running just a thin pass on something, it's very critical. I had an issue one time. We was busting some x-rays, couldn't figure out why. Come to find out, there were some manufacturer of the welding rods had this laid way back. So you had a lot more of rod there that didn't have the full composition of flux on it to cleanse the weld as it should. And a lot of the starts was ended up getting a lot of heavy porosity in it. And that's what it would come from. We finally got that figured out. But that's another thing that goes back into my mind that knows that when I do this, I eliminate the porosity on my starts. The second advantage to lighting that off and coming back to it is when your eyes see light, first thing they do is constrict. God made them that way, and it helps so you can see bright light, or they open up when it's not as much light. So when you light that off, your eyes will constrict, and then they'll come back. that gives you just enough time for your eyes to get back into focus to what they're doing or what they're seeing, so you can bring that back, and the back of that puddle end up where you left off or start up. You can see where you're starting off, and you're not blinded. You know, when you're not got that light still in your eyes. But anyway, it gives your eyes time to focus or refocus into the current light that it has at that time based on your lens shade and all of that. And you can get back and you can see what you're tying in, and it'll give you a lot cleaner tie in or a lot cleaner start. Ain't that pretty? All right. You'll see you got your 2 plates, piece of pipe. It don't matter. It's all the same geometry on the weld. If you can see right there, you can see where the old plate or the original bevel is. This out here is penetration and heat affected zone. That heat affected zone is how far you have heated that up in there. And when you etch one, polish it and put acid on it and etch it, you can see every bit of that right there. It'll all come through because you have diluted some of that weld and some of that parent material in there, and where the heat is, you've changed that. Now or changed a little bit of the molecular structure there. As you keep going through that, you'll refine it. But now, here's the deal on, you won't see me running a big wide weave, and this is exactly why. Where I was at, you go 3 times the diameter of the rod, and that was it. As if a 1/8 rod or 3/8 was as far as you was allowed to go. And the reason being on that is you'd heat that up and you go ahead and get out of there. But if you keep a wide weld on there, you heat it and heat it. It's cooling off. Heat it and cooling. Heat it, and then that there's cooling. You're heating this one, heating that one's cooling. As you do that, this heat affected zone starts getting bigger. How many people have you heard somebody say, well, it broke beside my weld, but my weld didn't break? It'll break right there in that heat affected zone a lot of the time. And that's why you want to heat it up, get out of there. And that's why we keep a stringer, little small stringers, and keep them going like that. I do not like running a wide, big weave weld, and that's why. Our procedure had 3 times the diameter of the rod or 11 times the diameter of a wire. So if you're running 0.45 wire, whatever 0.045 times 11 is, that'll tell you how wide you can run that. That's just the way it was, you know, and folks would sit there and say, well, we run this and we run this. I'm just saying, you can do it however you want to. This is the way we did it. It was proven. So you can't make me say this is wrong. I'm not going to say it's the only way to do it, but this is not a wrong way to do it. Now, as you're welding, let's say this is a piece of pipe, whatever. We've got this fitted up. All right, we got our bead in there, or root, depending on which part of the business you're in. If we're running pipeline, we're beading it. If we're sitting there doing combo welding, that's a root. We get this in here, whatever, the next pass that we're making, the only spot we're concerned with is, let's say, this spot to this spot. Because we want to tie that weld into this now. That's where we're at. And we want to tie this weld, those 2 welds and that one into there, or whichever bead sequence you happen to be in. If you on this next one here, all you worried about is tying that bead into that plate. Those places right there are where you are to concentrate what your weld is or where you're welding, because it don't really matter what's over here. That's what you're welding right there. So keep your concentration on where you're going there. Make that bead as smooth and consistent as you can. All right, a while ago we talked about starting weld. Now we're going into the weld. You sitting here welding your long. There's your bead right there. It's puddling up behind you and everything. When you get to the end, get right there and then turn around there and back up a little bit right there. Then all of a sudden, all of that will fill in, and then you won't have that, because if you're sitting there doing something where it tells you need a 3/16 inch weld That is a minimum weld requirement. You need to fill that up. I learned that the hard way one time. I worked to make sure it called for a 1/4 inch weld. We was running flux core. I made my weld exactly a 1/4. There was one spot there where I went over a tack. I kind of got in a little hurry, so it sucked down under it. I had to repair it. Did not like the way that repair looked, because that's when I got informed that weld symbol was a minimum requirement. You can go over a little, just don't go under. So when you get to the end of that weld, back up just a little bit, and then that'll let that fill in for you. You won't have that little concavity down there at the end. Plus, the other thing is you won't have a fisheye or a suck hole in there where you pulled out. So you can go back on that right there, and it'll kind of cool that off a little bit in that other weld, and she won't suck hole on you. Well, I got my old buddy y'all said he's gonna come help me try to get some videoing done and help me try to get my camera focused, get the shade right, and figure out where we can when I'm doing some welding, that I can get my camera focused so you can see what I'm doing. I don't want you to sit there and say, well, he's just doing a lot of talking, he can't show it. No, I ain't as good as I used to be, because my eyes and my hands don't work together like they used to. Used to, I'd be welding along there and my eyes are seeing it, my hands is doing it. Now I'm sitting there welding along there, my eyes see it, and ask my hands, what are you doing? So that's what happens when you go to getting a little older. It's not like you just keep getting better and better and better. Plus, I don't do it every day, so making an excuse or whatever you want to call it, it is what it is. When you get 67 years old, you'll know what I'm talking about. Seen people say, well, you need to follow a pattern, and you do. That pattern is of your choice, however that works out. Some people say, well, you need to do it this way, just weaving it back and forth. Some people say, well, to go like this, and that's the way I do mine, and man, it comes out perfect. Another guy sitting there said, I make circles. Mine looks perfect. Do whatever you need to do. Main thing you want to do is at all times maintain a fluid puddle. Whatever you can do to keep that puddle wet the whole time you're going. I know I got it held up here like we're doing vertical, but if I'm doing vertical, this is all I'm gonna be doing. I'm going from bevel to bevel, or a point in there the same every time, and keeping that puddle fluid and easing up to make this back here look like I was sitting up there with a jet rod just dragging it. I mean, that's the whole goal. And if you do it like this, it don't matter. I count. So if I'm doing it, I'm doing 1, 2, 1, 2, 1, 2. Same thing here. I go 1, 2, 1, 2, 1, 2, 1, 2. Just as the consistency of how you move it is going to determine what that weld's going to look like. So it doesn't matter whatever you do. To me, that's easier. I'm just keeping a fluid puddle and welding. That's all I'm trying to do. And if you want to think you got to do all this other stuff, and the thing about this is you got to move up consistently. This one right here, all you got to do is cut your last puddle in half. Last puddle in half. Last puddle in half. Keep right on going. Well, all right, I hope this little introductory part has been helpful to you and given you some things to think about and some stuff to maybe work on, or you want to go look it up. Go look up the code that you're going to be welding under. If it's D11 or 311 or API 1104 or ASME code, or whichever one you're going to be welding on, that's what we dealt with most of the time, was ASME code. API, a lot of that comes from the ASME. That's the American Association of Mechanical Engineers. There's a stack of books, volume 1 through 9. One is the boilers, boiler and piping, I believe. Section 2 is your materials. 5's NDE, 9's welding, 8, I believe, was nuclear. I don't really remember all of that. That was back in the late 80s, early 90s, so that's a good while back. But anyway, I hope anything I've told you there that you can use, you think about it. If you got a question on it, write it down. We'll try to answer it the best we can. Y'all be careful, stay safe, go to church on Sunday. See you later.